This is Euclid Book 10, proposition number 84. And it says the following. To a straight line which produces with a medial area, a medial hole only, what? Okay, this was going to get real tricky here, so let me read this again. To a straight line which produces with a medial area, a medial hole, only one straight line can be annexed, which is incommensurable in square with the whole straight line, and with which the whole straight line makes the sum of the squares on the medial, and twice the rectangle contained by them both medial, and also incommensurable with the sum of the squares on them. And I'm sure you're going, what in the world is he talking about? Okay, now considering how many times I've drawn out the squares and the rectangles, I think you can do this yourself. I will tell you which ones to draw, and you draw them yourself this time, okay? We're going to see how good you really are. This is your test here. Let AB be the straight line which produces with a medial area, a medial hole. And let BC an annex to it. Okay. So, where's the straight line? Well, this is AB, and this is the straight line right here. Okay. And we're going to produce a medial area and a medial hole. And we're going to annex BC, this right here, to this. That's what we're going to do. Okay. Therefore, AC and CB, well, this is AC right across here, and this is CB right across here. They are straight lines, incommensurable in square, which fulfills the aforesaid conditions. This is by Euclid Book 10, proposition number 78. I say that no other straight line can be annexed to AB which fulfills the aforesaid conditions. For if it were possible, let BD be annexed. This is BD right across here. So that AD, DB are also straight lines, incommensurable in square, which makes the squares on... Now, okay, here we go. I want you to take the length of AD right across here. See the length of AD right across here? I want you to make it into a square. That's the first thing I want you to do. And then I want you to take the length of BD right across here, and I want you to make it a square as well. Okay? And when you do, I want you to add the areas of AD and BD together. Okay? You've made a square out of AD, you've made a square out of BD. I want you to add the area of those two squares together. Okay? When you do, the sum of those areas is going to be medial. Okay? Now then, we're going to make a rectangle. Two sides of that rectangle are going to be the length of AD, right across here. Two sides of that rectangle will be length of DB, which is right across here. Now when you produce that rectangle, okay, you're going to take that rectangle's area, you're going to multiply it by 2, and when you do, you'll get a medial area. Okay. Now then, do you remember just a couple minutes ago when I had you draw two squares and I told you to add the areas of those two squares together? Okay. The sum of those two squares is incommensurable with twice the area of the rectangle I just had you draw. Okay. And that's by Euclid Book 10, proposition number 78. Okay, let a rational straight line EF be set out. This is EF right across here. Let EG equal to the squares on ACCB. Okay, now what is EG? Well, EG is this area here plus this area here. All of this is EG. Okay? Now, here's what I want you to do. I want you to take the length of AC. This is the length of AC right across here. Okay? I want you to take this length and I want you to make it into a square. Okay? And then I want you to take this length right across here and I want you to make it into a square as well. Okay? Now then, if you add the sum of the two squares you just drew, say, well, which two squares was that? Well, I told you to take the length of AC and make it into a square, and I told you to take the length of BC and also turn it into a square. You take those two areas and you add it together, and you'll get the area of all this. Okay? Alright. Now, we're going to apply this whole area to this line, and we're going to produce EM as the breadth. Now then, we're going to draw another rectangle. Two sides of that rectangle are going to be the length of AC. Here's AC here, and you're going to make a rectangle with two sides of it equal to that length right there. Now, what about the other two sides? The other two sides are going to be the length of this. Okay. Now then, what is HG? Well, that's HLGM. That's this area right here. Not this, just that. Okay? Now, this area right here is the same amount of area as if you were to take the rectangle I just had you draw and multiply its area by 2. Alright. And if you do that, because what you're doing is you're applying to EF, or actually in this case to HL, all this area here, you're going to apply this area to this, which happens to be the same length as this, and you're going to produce HM as the breadth. Okay. Now then, what is the square on AB? Okay, you're going to take this line right across here, and you're going to turn it into a square. Okay, and all four sides of that square are going to be the length of AB. And that square AB is a remainder. Okay? And that's by Euclid Book 2, proposition number 7. Now, that square AB, being a remainder, has the same amount of area as EL. Okay? This area here is the same as the area of the square of AB. Therefore, AB is the side of EL. Again, let EI, okay, now what is EI? It's this, plus this, all of this together. Now, what's it equal to? Alright, do you remember that square I had you make that was all four sides with the length of AD? And do you remember the square I had you make in which all four sides with the length of DB? Okay. If you take the area of AD, that square there, you take that square area, and you take the area of the square DB, and you add them together, then you will get all of this. All of this area equals that sum. And all of this area has been applied to EF, which produced EN as the breadth. But the square on AB is also equal to EL. Okay, remember we said that the square on AB is equal to this. Therefore, the remainder, twice the rectangle ADDB. Okay, that means that you have a rectangle now, two sides of which are going to be the length of AD, two sides of which are going to be the length of DB. Okay. Alright. If you take that area of that rectangle that's two sides AD and two sides DB, and you multiply that area by 2, then you will get the area of HI, which is this plus this. All of this is twice the area of ADDB. This is by Euclid Book 2, proposition number 7. Now, since the sum of the squares on ACCB is medial and equal to EG, right here, therefore EG is also medial. This whole area is medial. And it has been applied to the rational straight line EF, producing EM as the breadth. Therefore, EM, this length EM, is rational and incommensurable in length with EF. This is rational, and it's incommensurable with this. This is by Euclid Book 10, proposition number 22. Again, since twice the rectangle ACCB, okay, so that means two sides of the rectangle would be AC, the other two sides are going to be the length of CB. Okay. Twice of that area is medial, and it's equal to HG, which is this right here. Therefore, HG is medial. Okay. And it has been applied to the rational straight line EF, producing HM as the breadth. Therefore, HM, this line right here, is rational, and it's incommensurable in length with EF. HM and EF are not commensurable, and this is by Euclid Book 10, proposition number 22. And since the squares on ACCB are incommensurable with twice the rectangle ACCB, EG is also incommensurable with EG is also incommensurable with HG. Okay? EG, which is this whole area right here, is incommensurable with just this. Both of these together is incommensurable with just this alone. Therefore, EM, this line right here, is incommensurable in length with HM. EM is incommensurable with HM. This is by Euclid Book 6, proposition number 1, Euclid Book 10, proposition number 2, and both are rational. Okay, that means that EM is rational, HM is rational. Therefore, EM and HM are rational straight lines commensurable in square only. Therefore, EH is an apotome. This line right here is an apotome. And HM has been annexed to it. Okay? This is by Euclid Book 10, proposition number 73. Similarly, we can prove that EH is again an apotome and HN has been annexed to it. This is an apotome. And now we're going to annex HN to it. Therefore, to an apotome, different rational straight lines are annexed, which are only commensurable with the holes of square only, which was proved impossible by Euclid Book 10, proposition number 79. Therefore, no other straight line can be so annexed to AB. Therefore, to AB only one straight line can be annexed, which is incommensurable in square with the whole, and which with the whole makes the squares on them added together medial, twice the rectangle contained by them medial, and also the squares on them incommensurable with twice the rectangle contained by them. Now you say, wow, that was a lot of stuff. Well, I got more for you. Euclid Book 10 has 3 sets of definitions. Guess what? We're going to read the last definitions of Euclid Book 10. Definition number 1. Given a rational straight line and an apotome, if the square on the whole be greater than the square on the annex by the square on a straight line commensurable in length with the whole, and the whole be commensurable in length with the rational straight line set out, let the apotome be called a first apotome. Now here's the kick. We're going to be finding the first, second, third, fourth, fifth, and sixth apotmes in the next few proofs. Okay, so if you don't understand these right off the bat, you will. But if the annex be commensurable in length with the rational straight line set out, and the square on the whole be greater than the one, then and the square on the whole be greater than that on the annex by the square on a straight line commensurable with the whole, let the apotome be called a second apotome. But if neither be commensurable in length with the rational straight line set out, and the square on the whole be greater than the square on the annex by the square on a straight line commensurable with the whole, let the apotome be called a third apotome. Again, if the square on the whole be greater than the square on the annex by the square on a straight line incommensurable with the whole, then if the whole be commensurable in length with the rational straight line set out, let the apotome be called a fourth apotome. If the annex be so commensurable, it's a fifth, and if neither, it's a sixth. And that ends that proof at long last. Okay. Wow. Now we can proceed on with the final proofs of Euclid Book 10 and hopefully finally reach Euclid Book 11 where we start with 3D proofs. Yeah, that's going to be really exciting. Alright, I will tell you more in a future video. Stay tuned.